Dear student, now we see the topic problems based on fixed point or invariant point. Okay, read the first question. Find the fixed point of W which is equal to 2zi plus 5 divided by z minus 4i. Okay, first we take the given value W which is equal to 2zi plus 5 divided by z minus 4i. Already explained the definition of invariant point. The definition of invariant point can substitute the W value is equal to W, you can write the f of z, you can substitute the z, that is W value you want to substitute the z. Okay, so here we take this given problems. W which is equal to 2z plus I divided by 2zi plus 5 divided by z minus 4i. Put W which is equal to z. By using the definition of invariant or fixed point, you can substitute put W equal to z. So left side has the W, so you want to substitute the z. So z which is equal to 2zi plus 5 divided by z minus 4i. Next, using the cross multiplication, that is z into z minus 4i which is equal to 2zi plus 5. The multiplication of z inside the value, z into z, you can write z square minus 4zi. So right side values of in this value will get the left side. So plus 2zi become the minus 2z, plus 5 you can write the minus 5 which is equal to 0. That is z square, add these two terms because these two terms is same. Minus 4zi minus 2zi, add this become the 6zi minus 6zi minus 5 which is equal to 0. So directly can find the factorized value. So that time you can using this formula. Here A value 1, B value minus. So this problem is based on the you can using apply the second order equation. A x square plus bx plus c equal to 0. So compare this equation. You can write the here A value as the z square coefficient is a value and z coefficient is a b value. Constant value like that is c value. Okay, but here z square coefficient is a value, that is a value is z square coefficient 1. You can take the a value is equal to 1, and z coefficient is a b value, that is b which is equal to minus z coefficient has a minus 6i, and the constant of c value has a c equal to minus 5. By using the formula z which is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay, so apply this formula. You can substitute all the values a, b, c value this formula. That is minus into b value minus 6i plus or minus of root of b square value minus 6i the whole square minus 4 into a value, you can substitute 1 into c value minus 5, and whole divided by 2 into a value, you can substitute the 1. Simplify this value. Minus into minus become plus 6i plus or minus root of so negative square become the positive 6i the whole square value 6 square that is a 36, but I square value is a minus, so you can write the minus 36. So multiplication of first is multiplication of the sign value. Minus into minus you can write the plus 4 pi's are 20 and divided by 2 into 1 2. That is 6i plus or minus subtract this value, that is minus 16 divided by 2. 6i plus or by root of 16 minus 16 value 4i divided by 2. So add this value and subtract this, add and subtract this value. 6i plus 4i divided by 2 comma 6i minus 4i divided by 2. So in this value become 10i by 2. Subtract this value, 2i divided by 2. 2 values cancel, 5 2s are 10. So finally it can become the fixed point is, therefore the fixed point of z is 5i comma I. Next, see the next problem. Find the invariant point of the bilinear transformation z minus 1 divided by z plus 1. Already I told you fixed point or invariant point. This problem is mentioned the invariant point or fixed point. So given the value, let us take w which is equal to z minus 1 divided by z plus 1. Next, substitute the put w equal to z by using the definition of invariant or fixed point. W value want to substitute the z. that is z equal to z minus 1 divided by z plus 1. Using the cross multiplication, z into z plus 1 is equal to z minus 1. All the values will be get the left side, that is z square plus z minus z plus 1 replaced by minus 1 replaced by plus 1 equal to 0. Here plus and minus z is cancelled. Finally, you can take z square plus 1 equal to 0. Therefore, the z square is equal to minus 1, that is z equal to plus or minus of I. Next, see the next problem. Find the invariant point of the function f of z equal to z cube plus 7z divided by 7 minus 6zi. Okay, so given the value, take f of z equal to z cube plus 7z divided by 7 minus 6zi. So f of z value, you know, that is a w. Okay, that is f of z, you can substitute w is equal to z cube plus 7z divided by 7 minus 6zi. Here we put w equal to z, substitute this here, that is z equal to z cube plus 7z divided by 7 minus 6zi. Using the cross multiplication, this value, that is z into 7 minus 6zi, which is equal to z cube plus 7z. Okay, therefore the z cube plus 7z, so this value multiplication of right side value, that is z square 7z, first multiplication this value 7z minus 6z square I, which is equal to z cube plus 7z. So left side will we get the right side, that is z cube plus 7z minus 7z plus replaced by minus replaced by plus 6z square I equal to 0. Here plus 7z minus 7z cancel. I can write the z remaining value, take z cube plus 6z square I equal to 0. These two terms z square is a common, take outside, that is a remaining value can take z into z plus 6i equal to 0. That is z square equal to 0 and z plus 6i equal to 0. Therefore, the z equal to 0 and z equal to minus 6i. Therefore, the invariant point is 0, minus 6i.